Hello everyone. Welcome to a new DMD Hangar team video tutorial. Today we will guide you step by step through the integration process of new weapons into the multiplayer shooter system in Unreal Engine 5. Our goal today is to help you achieve a functional and solid implementation using the system standards. The first thing we need to look at are the resources required for this process. For this tutorial, we have imported a new example weapon and placed it in a separate folder to keep our workflow clean. The MSS is built to work with animated weapons. Therefore, your asset must be a skeletal mesh. To fully utilize all the weapon features within MSS, it is crucial that the mesh follows these technical specifications. The main pivot point must be located at the grip, ensuring the weapon attaches perfectly to the character's right hand, and the mesh must be oriented towards Y+. The magazine mesh must be separated from the main weapon body, with its pivot point placed exactly where the magazine bone should be. This allows the system to spawn a physical magazine with proper physics during the reload sequence. Finally, since we are using physics for both the weapons and the magazines, make sure that both meshes have their collisions correctly set up. In addition to the mesh, we will need at least a reload animation and, optionally, a firing animation for the weapon. It is highly recommended that both animations have the force root lock option enabled in their settings. This ensures there are no offset issues or unwanted movement relative to the character's hand during playback, keeping the weapon perfectly aligned at all times. Naturally, we will also need the character's reload animation that matches the type of weapon we are integrating. To achieve a professional and realistic result for the player, it is highly recommended that both the character and the weapon animations have the same duration and are perfectly synchronized. In this tutorial, to simplify the process, we will use the animations already included in the MSS for the rifle. MSS weapons use a specific bone called magazine to attach the mag. However, in many cases, like this example, the weapon might come with a different bone nomenclature. To fix this, we will manually create a socket on the corresponding bone and name it exactly as the system requires. To ensure millimetric precision, we'll temporarily add the magazine static mesh as a preview mesh to the socket. This allows us to verify if the bone's orientation and location are correct, letting us adjust it visually until it fits perfectly. The next step is to prepare the weapon's animation montages, so it can correctly play the firing and reloading sequences. We will take this opportunity to add the reload sounds directly into the animation. This way, we can visually synchronize them by creating sound notifications. The project includes a wide variety of ready-to-use sounds. In this tutorial, we will use the notifications already set up in the original rifle's reload animation, as they are perfectly synchronized with the movement timings we are looking for. Another essential configuration is the anim notify sequence within the character's reload animation. This is where we tell the system the exact moments to execute specific logical actions. Take magazine, for when the hand removes the mag. Spawn magazine, to visually create the new magazine. Drop magazine, to trigger physics and drop the old magazine to the ground. Place magazine, to finally attach the new magazine to the weapon. Additionally, it is vital to create an animation curve named IK left hand. In this curve, we define when the left hand's IK is enabled or disabled. A value of 0 means the hand is gripping the weapon, while a value of 1 tells the system the hand is free to perform the reload. To ensure the reload animation doesn't interfere with the leg movement, we must assign our montage to the upper body animation group. By doing this, we allow the engine to perform layered blending, executing the reload only on the upper body. Now that our meshes and animations are set up, it's time to start building the weapon's logic. The first step is defining what we are actually firing. MSS features two main ammunition systems, laser and projectile. Since we are integrating a conventional rifle, we will choose to create a new projectile. To do this, we are going to create a child blueprint from BP Projectile Master. By inheriting from this master class, our projectile will already have all the necessary replication and impact detection logic from the system. It is very important to give it a clear and descriptive name so we can easily identify it later when we link it to our weapon. Upon opening the details of our new projectile, we can leave the projectile activated by default so it executes its logic immediately upon collision. We determine if the damage is applied at an exact point or within a radius. It is possible to define a lifespan, so the object automatically destroys itself after activation. If we choose radial damage, we can adjust the explosion parameters. In FX, we can assign the decal impact mark, the impact sound, and the particle effect triggered on hit. We can also adjust the collision box scale, countdown sounds, if the countdown is enabled, and of course, the projectile's visual appearance, including its scale and color. Remember, you can always create your own custom assets and add them to give your weapons a unique touch. Once our projectile is defined, the next step is to create the physical magazine our weapon will use, which can be dropped during the reload sequence. To do this, we are going to create a child blueprint from the BPLW magazine masterclass. We'll save it in our organized folder to keep the project tidy. This actor is what the system will dynamically spawn when we trigger the drop magazine notify we previously set up in the animation. Inside the new magazine we've created, let's assign the corresponding static mesh and review its properties. A key parameter is the lifespan, which allows us to determine how many seconds will pass from the moment we drop the magazine until the system removes it from the world. We have an option to determine if the magazine material is shared with the weapon's body material. Now it's time to centralize all the resources we prepared into one place, our new weapon. To do this, we are going to create a child blueprint of BPLW Master. This is the master blueprint responsible for managing all the interactable weapons our character can equip, fire, and drop. The first thing we need to do after creating our new blueprint is to go to the component called Body. This is where we will assign the skeletal mesh of the weapon. In order for our weapon to visually play the firing and reloading montages we prepared earlier, it is essential to create its own animation blueprint. Once created and assigned to our weapon skeleton, we will head into the anim graph. We must add the slot node and connect it to the final pose output. This enables the weapon to receive and execute any animation montage called by the system's logic. Don't forget to assign this new anim blueprint to the body component of our weapon actor so everything is properly linked. Let's start configuring its parameters in the Details panel. This is where we define how it behaves and how it is displayed in-game. Weapon class. This determines which inventory slot it belongs to. In this case, we will set it as a secondary weapon. Weapon type. It identifies the weapon type so the MSS knows exactly which set of character animations to use when the player has it unholstered. Magazine actor. We must assign the physical magazine blueprint we created earlier. Once assigned, you will see it automatically previewed on the weapon. We will type the name we want to appear when interacting with it. Image. We will assign the texture that will represent the weapon in the HUD. Rarity. This is a variable designed for looter-style games. It determines the rarity level and the associated color in the UI. Later on, I will explain how to fully customize this feature. Collision distance. This variable determines the physical length of the weapon, so the system can detect collisions with the environment. To adjust this value with precision, I recommend enabling the debug mode for the shooter system component on your character. Let's add the key animations. Parent anim pickup. Here, we will assign the character's animation for picking up this weapon from the ground. Parent anim equip. This is the animation the character will execute when holstering and unholstering the weapon. Anim shoot. We will place the weapon montage we created specifically for when firing. Anim reload. The weapon's reload montage. Parent anim reload. We assign the character's montage performing the reload action. Parent anim dry fire. The character's animation when attempting to fire or reload with no ammo in the reserve. Hold time. This variable determines how many seconds the player must hold down the interaction button to pick up the weapon from the ground. This is where we can determine which crosshair our weapon will have. In a project, you will find different crosshairs already configured for each weapon type, and you can swap or modify them without any issues. Let's take a quick look at all the customizable values offered by the crosshair material. For this tutorial, we will use the crosshair already configured for the rifle, which is perfect for demonstrating how the HUD reacts to our actions. It is crucial to understand how these three dispersion multipliers directly affect the crosshair material. Dispersion aim. This is a multiplier that acts on the material's dispersion variable as soon as we aim down sights. Dispersion shoot. This value multiplies the expansion effect with every shot we fire, allowing the crosshair to visually expand to represent recoil and loss of accuracy. Dispersion movement. This parameter multiplies the dispersion effect if the character is moving, signaling to the player that their accuracy decreases while on the move. We are now entering the FX section, where we will configure all the visual and sound feedback. Fire alternately. This option allows for alternating shots between different exit points if our weapon has multiple BP muzzle components. Laser aim. This allows for the creation of laser pointer logic when the weapon spawns in the world. Trajectory path. This allows for the creation of trajectory logic when the weapon spawns in the world. Projectile. This is where we must assign the custom projectile we created earlier. Projectile shell. This is the particle spawned when firing to simulate bullet casing ejection. We select the muzzle flash. The project includes several examples, but you can use your own custom assets. Muzzle sound, the sound that will play with every shot. Camera shake. We assign the blueprint that generates camera vibration when firing. The project offers various examples depending on the weapon's caliber and recoil. Force feedback effect. This asset defines the controller vibration when firing, with specific examples for each fire rate. We are now entering the technical damage configuration, where we define our weapon's offensive power. Damage. This determines the base damage each weapon impact will deal. Critic multiply. This is the multiplier applied to the base damage when hitting an enemy's weak spot. Elemental damage. We can define if the weapon has a special damage type, like fire, electricity, or ice, allowing for more complex mechanics. Damage spread. By enabling this option, we allow the damage to vary, adding a range of randomness to each hit. Percentage spread. This value determines the percentage of base damage that can randomly vary up or down. Min spread. This is the guaranteed minimum damage the weapon will deal, useful for ensuring damage never rounds down to zero in complex calculations. Now we will configure the firing behavior and weapon ballistics. Shot type. This determines the fire mode. For this rifle, we will set it to automatic, allowing for continuous bursts while the trigger is held. Number projectiles. This variable defines how many projectiles are spawned simultaneously with each shot. It is extremely useful for creating shotguns. Fire rate. Here we set the delay between shots, calculated in seconds. A lower value will result in a faster rate of fire. Projectile speed. We define the projectile's travel speed. Recoil force. This is the projectile dispersion multiplier. The higher this value, the wider the randomness radius will be for each shot. Recoil max. This allows us to readjust that dispersion for even finer control. Usually, a value of 1 is the sweet spot for most weapons. Recoil movement. This is the multiplier that increases dispersion when firing while the character is on the move. Recoil location and rotation. These values define the position and rotation offset for the right-hand IK when firing. Burst shots and burst delay. If we set the weapon to burst mode, here we determine how many projectiles are fired per burst and the delay between them. Max rounds and max ammo. Here we define the magazine capacity and the maximum ammo limit the player can carry in reserve. Parent material. An ideal option for MSS modular weapons. If enabled, all attached parts will share the same material. If disabled, we can assign independent materials to each attachment or weapon part. Now that we are familiar with all the weapon's logical properties, it's time to place the essential components in their correct positions within the viewport. We'll start with the casing direction. This component is represented by a green arrow and shows the exact orientation where the projectile shell particles we selected earlier will be spawned. We're going to move and rotate it until it's placed right at the weapon's ejection port, making sure the arrow points outward so the shells are realistically ejected when firing. The component named Sphere is the sphere collision responsible for detecting any controlled pawn. When a pawn enters this radius, the system recognizes that the weapon is interactable and will automatically display the interaction widget. The W interaction component contains the interaction widget that the player will see on screen. By default, this component is located at the actor's center, right at the weapon's origin. The BP muzzle component is responsible for telling the system's logic exactly from which point the projectiles and the muzzle flash should spawn. We simply need to drag it to the tip of our weapon's barrel. One of the great advantages of the MSS is its scalability. You can add as many BP_muzzle components as your weapon has barrels, and the system will handle the projectile spawning automatically. A very important detail is that the BP_muzzle already has the BP_trajectory_ path integrated by default. If we enable the trajectory option in the weapon details we saw earlier, this component will handle calculating and visually drawing the path the projectile will take. Finally, we have the BP aim laser component, which, if previously enabled in the weapon details, will automatically generate a functional laser pointer. While we have the freedom to place it anywhere on the weapon's body, in this case, we will place it right on the barrel. This ensures the laser beam aligns perfectly with the center of the screen, serving as an infallible visual guide for the player during combat. The moment of truth has arrived, testing our new weapon in the practice map. We're going to drop the actor directly into the scene so we can pick it up with our character. As you can see, the firing system works perfectly. Particle effects and muzzle sound are exactly where we placed them. When reloading, the animation ejects the physical magazine realistically, and the sequence finishes successfully. Furthermore, the projectiles are correctly dealing damage to the destructible actors in the environment. The holstering and unholstering animations flow well, and the weapon automatically equips into the secondary weapon slot, just as we specified in the details. Even swapping between weapons works flawlessly, confirming that all the MSS logic is operating as it should. However, we still have some visual fine-tuning to do. As you can see, the left hand's position isn't gripping the handguard correctly. Fortunately, we can solve this issue easily and in real time. While in play mode, we can press F8 to enter spectator mode. This allows us to move the camera freely and precisely visualize the left hand's position relative to the handguard. We select our IK hand left component in the weapon blueprint and adjust its position and rotation. Once we're satisfied with the result, we just need to compile the blueprint to save the adjustment permanently. Now that the weapon is functional, let's give it that true impact feel when firing. If you look closely, both the crosshair and the recoil dispersion aren't reacting naturally right now. We'll increase the recoil force so the bullets don't always hit the exact same spot during full auto fire, and we'll fine-tune the crosshair multipliers we saw earlier. We're going to adjust the crosshair dispersion values. We want a player to visually feel how they lose accuracy when performing certain actions. To prevent all projectiles from hitting the exact same spot, we are going to adjust the recoil force. By increasing this value, we expand the bullet's dispersion radius, giving each shot a slight random variation. This simulates the real instability of a weapon during sustained fire. But recoil isn't just ballistic. It also needs to be visual on the character's body. Therefore, we will adjust the recoil location and recoil rotation for the right-hand IK. By setting this offset, we'll see the character's arm physically kick back with every shot, conveying a much more immersive sense of power and kick with every trigger pull. As you can see after these final tweaks, the crosshair now has a much more organic reaction to the player's movements and the weapon's fire rate, expanding dynamically as the dispersion increases. Additionally, the projectiles now have a larger but controlled dispersion area, which provides much-needed ballistic realism. If you look closely, the weapon generates a subtle recoil in the right hand, which, combined with a camera shake effect, gives us a sense of real and powerful recoil. With this, our weapon is not only functional, but feels alive in the character's hands. Finally, we'd like to let you know where the general data for the project's visual identity is stored. To unify and maintain a cohesive look, there is a data table called DT Visual Data. From here, you can centrally configure all the UI elements and colors used. It's the perfect place to set up different item rarities and their associated colors, as well as ammo and elemental icons. This ensures that if you decide to change a color or an icon, it updates automatically throughout the entire game. That's it for our tutorial on integrating new weapons into the MSS. Remember, you can join our Discord for direct support and to clear up any questions. As always, thank you so much for your support and see you in the next video.